We'll be doing the Energy Skatepark Basics simulation on the PhET website today, and the link will be posted in Google Classroom, along with a link to this video in case you needed to watch any of the steps again. So we click on the link, brings us to this page, we click the play button. This one should start right away. And just like other things that we've seen, we have different tabs or different screens that we can go into. And of course, we're going to start with the intro. So for this one, we have a skateboarder. We have different options on the side over here: pie chart, bar graph, grid, speed. You can change the mass of the person. Just leave it where it's at for now. You'll need to select things based on what it asks you to do on the worksheet, whether you need to make a bar graph or a pie chart. And it's color-coded: green for kinetic, blue for potential energy. Okay, those are the things we talked about yesterday. Potential energy being the energy stored because of position, and in this case it's going to be height. And kinetic energy, the energy of motion when the skateboarder is moving. You'll also see on this an orange key here for thermal. On this intro tab, thermal energy is not going to show up on your graphs because on the intro tab, we're not going to have any friction. So we're not going to have any of that energy converted, remember that means changed, into thermal energy. We'll see that when we do the friction tab later on. So to get this started, you simply click and drag and put your skateboarder on the top. Now you'll notice right away I'm just kind of clicking and holding here. The graph is automatically generated, both the pie chart and the bar graph. We see the total amount of energy on the bar graph, that's yellow there. And we see right now all of its potential. I have not let the skateboarder go. In our pie chart, it's all potential too. We don't see anything yellow for total because a pie chart, 100% of it is total. So I would let this person go, and I will let them just do their thing for a bit here. You see the pie chart change. You see the bar graph change. You can also, down here, click and see it in slow motion. And you can pause at the top, or pause at the middle, halfway between where they started and the bottom of the ramp. Pause when they're at the bottom. So based on different things that it asks you to do on the worksheet, you might have to pause to get a good look. You can also pause and take it frame by frame forward by clicking this button right here. I'm going to put it back to normal though. So this is just the U-shape ramp. All of the things that I ask you to do for the intro tab, which is part A on your worksheet, is using this ramp. You can also go in and you can check out this one as well. Although this one, goodbye. We also have this as well. So there's some other things you can explore on here, but make sure you don't spend too much time. Please make sure you are completing the tasks on the worksheet. If you finish the activity sheet that goes with this simulation, and you finish the energy form and changes activity from yesterday, which I know a lot of you are, or a lot of you are pretty close to being done, then you can spend time at the end of class exploring this simulation or the energy form and changes. So make sure you don't just spend too much time exploring this. Make sure you are doing the things that you need to do to accomplish the task to show what you are learning. Once you finish part A, which is the intro tab, then you will click on the friction tab down here. Looks very similar, right? There's our U-shaped graph. I'm going to put on the pie chart. I'm going to put on the bar graph again. The grid would be if we were doing some graphing points, which we're not. We can also put a speedometer up as well to see their speed. Now for this one, if we have friction, which we can change to lots of friction, to no friction, so just a little bit there all the way up to lots, we'll be seeing what happens to the thermal energy here. What's going to happen if we do have friction, if we do have the wheels rubbing up against this ramp, what would actually happen? Something to pay attention to. Anytime it's paused, please notice the bars, both in the intro tab and the friction tab, and notice if you were to add them up, what would they equal? What would the heights of those bars equal? Hopefully hopefully you notice that right away. So we see it's a little bit different here now with the friction tab on, because some of the energy that we start with, some of that energy that's stored up because of their height, as they're going down, it's not just all being turned into kinetic. Now, some of it is lost to the environment. It's converted into thermal energy, and then eventually this person would stop. Okay? So for this sim, we're using just potential energy. We're not adding any energy into the system. The person's not moving their leg and continually adding, just like we had the simulation yesterday with the girl who kept pedaling on the bicycle, right? This is just powered simply by gravitational potential energy, how high that person is on the ramp. So part A is the intro tab, part B is the friction tab. Once you complete those two, then you can go into the playground tab. Now for the playground tab, we see we have the same options over here. Now we're going to have a couple of different things as well, which I'll show you what these two are in a moment. But here's where you can create your own track. So we do that, click on the wrong thing, by grabbing this bar, and you can move these red dots around to move things the way you want them to. And those dash lines are where you can connect. So we can make loops. We can make hills. Oops. Make sure you are thinking, though, about what you know about potential energy to kinetic energy when you are doing this, okay? So there's some different things that we can do here. You can delete things, you can move things around, we can erase, we can start over. You're going to need to design a track and then test it, see what happens. If it doesn't work, you're going to have to fix it until it does. This is part C. You'll answer some questions there. Now I am going to go back really quick because I do want to show you what this last little option is. So if we were to put the person up on the, I'm going to hit pause here, so they just stand here. So you see that little red dot? This first option would snap the skateboarder to the track, okay, almost like they're connected on. This one, they could fall off potentially. They're not going to be snapped to the track, so you can kind of see that with the little red dot and the picture. So if we were to have a loop here. So we'd be watching what's happening. If we have it snapped to track, they would say stay snapped on. Uh-oh, you're going to have to figure out what you would need to do to get them to complete whatever obstacles you make. This one would have them not snap to it. So even if they were able to go around, they could possibly fall. So you need to make sure I would just keep it on this one. You can also see what happens with this. There's no questions that involve you having to use this option. You can keep your skateboarder snapped to the track the whole time. That's totally fine. And again, you have the same options over here as well. So we have the playground, friction, and the intro. Hey, look, they're still going. Should be pretty easy. We've done enough of these sims and we see a lot of the same different formats that they use, so you should be able to figure this out pretty well. Colored pencils, you'll need just a handful of colors. You are welcome to borrow mine, but please make sure you return them. And yeah, when you are done with this, make sure you have your energy forms and changes activity done from yesterday, and then you could possibly spend some time exploring and seeing some other things that you can do with these energy simulations. I will see you tomorrow. Good luck.